All right, good morning. So, hopefully, you and a partner have been able to work on a couple of these problems on pages 14 and 15. And I'm going to go over the answers with you now so we can make sure that you are understanding this okay. Yes, I am going to be out for the rest of this week, and we are just doing the best we can because that's not ideal, but we will make the best of it. Okay? All right, so task number 7, writing linear equations in the context of these story problems. Says for each situation, determine the slope, y-intercept, and x-intercept along with the real world meanings when applicable. Additionally, write an equation to model the situation. Maybe the equation should be written in the form most appropriate for the information provided. All right, so here is problem 1 on page 14. It says to prepare for a recent road trip, Jill filled up her 19-gallon tank. She estimates that she used about 3 gallons per hour. Write an equation to model the amount of gasoline in her tank after T number of hours. Okay? So, most of the time, since we are talking about a linear equation, we are used to that being in the form of slope intercept form, which is, let me write this down first, slope intercept form. Y equals mx plus b, okay? Where m is equal to the slope, which we've talked about slope recently. That's the change in y over the change in x. And b is equal to the y-intercept, the place that on a graph that the x value is equal to 0 and the y value is whatever it is when time is equal to 0. Usually time is equal to 0. Okay? So this gal, Jill, is filling up her 19-gallon tank. Just to let you know, I have a Honda Odyssey, and that's a 20-gallon tank. So she's got a pretty big gas tank there. She estimates she uses about 3 gallons per hour. She's using it. Okay? It is being used. So if you think about that, if she is using up the gasoline, is the amount of gasoline increasing or is it decreasing as she's using it? Yeah, it is decreasing. Okay? Write an equation to model the amount of gasoline in her tank. All right, so let's think about this. She has a 19-gallon tank to begin with. Okay? And she filled it up. So she has 19 gallons at the beginning. Okay? She is using 3 gallons per hour. All right? Using 3 gallons per hour. Write an equation to model the amount of gasoline. Well, let's talk about this. As I look at this, and when she has 19 gallons of gasoline because she had just filled up her car, that is the amount of gasoline she has in the very beginning before her road trip. Okay. What would that be in terms of a graph? So, in terms of a graph, we're looking at something like this. You know, here is time, probably down here. Well, and this is number of gallons of gas. So when time is 0, she hasn't left for her road trip. How many gallons of gasoline does she have? She has 19. So we're going to say this is 20. That doesn't look like a 2. And this is 10. Okay. So she has 20 gallons of gasoline when right after she fills up. Let's say that's like right there. Can't see that very well. Okay, so that is the point 0.19. That is the y-intercept because that point is on the y-axis. When we make a graph, which maybe we will end up doing, it's on the y-axis, so it's the y-intercept. So the y-intercept here is 19, or you can say 0.19. Okay. Real world meeting, this is the amount of gas in tank before starting the road trip. Okay. All right. And so she is going down the road. She's estimating that she uses 3 gallons of gasoline per hour. Okay? 3 gallons of gasoline per hour. So if she is using it, she is losing it. It is decreasing. So that's going to be 3 gallons less per every hour. So her slope is a -3 over 1. -3 gallons of gasoline for every 1 hour. So her slope is -3. What does this mean? She is using, or AKA, also known as losing, 3 gallons of gasoline every hour. Okay? So eventually, if she only starts with a limited amount of gasoline, that amount being 19 gallons, she is going to run out. Okay? So the x-intercept means that at some point, okay, if I look at this, the x-intercept means that at some point she's going to have a length of time, okay, we don't know what that is exactly, but it is decreasing 3 gallons every 1 hour, okay? So if it's at 19, she would go 19 minus 3, down 3, and over 1 would be 16. And then from 16 down 3, oh, here's my 1, I guess. And I don't know that this is great. Down 3 from 16 minus 3 is 13. And over 1. That would be 13 minus 3 is 10. And over 1. 10 minus 3 is 7. Over 1. 7 minus 3 is 4. Over 1. 4 minus 3 is 1. Over 1. 1, 1. And then down 3 over 1. So these are my points. And she's going to hit about right there, the x-intercept. Down 3 over 1. I don't have a nice graph there And unfortunately, my brain's not hitting on all cylinders. So I can tell you the real world meeting is the time at which Jill has no more gasoline in her vehicle. Okay, let me refer to my handy little cheat sheet here and see what it says. Yes. Okay. So, as I was looking at that, and we were at down to like 1-1. So we got to 6, and she was at 1-1. And then we would go down 3, but we don't have to go down 3 because we're only at 1-1. So basically, it is taking her 6 and a third, or 6.3333, to reach that x-intercept. So the x-intercept is going to be 6.3 repeating, comma, 0. And so she has taken 6 hours and a third of an hour, which would be 20 minutes. So you could say 6 hours and 20 minutes to run out of gasoline from that 19 gallons of gasoline. Okay. And real world meaning, another way to say it, as I'm looking at my thing here, is that it will take 6.33 hours before her gallons of gasoline are used up. So the equation that we're looking at, and I think it said, write an equation to model the situational equation that should be written in the form most appropriate for the information given. Well, the information given says that she had a 19-gallon tank. Okay, so for her, she started out with 19 gallons. She is using 3 gallons per hour. Okay, using 3 gallons per hour. Somewhere, does it say something about using T? So she starts with 19. She is losing 3 gallons of gasoline per hour. Why do I have T? Does it say something about T? Oh, maybe that's the time. Losing 3 gallons and the time of an hour, which you can change that to be 1 hour, 2 hours, 3 hours, etc. And that tells you the number of gallons of gasoline that she has left after how many hours. So T is equal to the number of hours, and G is equal to the number of gallons of gasoline she has left after that number of hours. So yes, while we can always refer back to y equals mx plus b, this said to put it in the form most appropriate for the information given. It still is in that form, but it is moved around. Okay? All right. Let's go to the next problem. Roberto deposits the same amount of money each month into a checking account. Use the table to write an equation to model his balance B after M months. Okay. All right. So slope. Real world meaning. Y-intercept. Y-intercept. X-intercept. Equation. All right. So we have number of months and we have balance. Okay. So as I'm looking here, this is an increase of 2. And in that increase of 2, if I do my math correctly, we have $115. So that means for an increase of 1 would be half that amount. So if I started at 0 number of months, half of 115 would be, oh geez, what am I going to give for a calculator? I've got my phone here handy. It's like 107 or 57.50 maybe, something like that. Calculator. So 115 divided by 2, 57.50. Remember, we're talking about money, so we have to make it 50 cents. All right, so if after 1 month he had $255, then and based on this, that we know we gain $57.50, I should subtract that amount. Oh, shoot. So 255 minus 57.5 is 197.50. So that means when the account was first made, we had $197.50. And then each month, we are gaining $57.50. Okay, so let's see here. From 3 to 6, that's an increase of 3. And if we think that every month there's a gain of $57.50, this should be whatever $57.50 is times 3. So 57.50 times 3 is 172.50 plus 365 and I got 537.50. And what did I do wrong? Oh, that's not $115. Where did that come out? Let's try this again. Okay. So from 255 to 365, I see now that is even $110. So if that is over an increase of 2 months, then 1 month would be half of that. 1 month is going to be $55. So if going backward, if the money is increasing, if I go back to when the account was first started, going back $55, this would give me $200. Okay, 55, 365. So 3 times 55 is going to be 165, which works out to be 530. Okay, that works. So the slope is the increase in the amount each time. The slope here is going to be 55, or 55 over 1. The real world meaning is that every month Roberto deposits $55 into the account. Okay. The y-intercept is when x is equal to 0, and we already kind of figured that out. The $200, what does that mean? That is the amount of money in the account when Roberto opened it. So he initially either put in his own $200 or someone gave him some initial money, maybe for graduation or something, and he deposited that $200. And then after that, he continues to add to that an amount of $55 every month. Okay, x-intercept. That is where the graph is going to cross the x-axis. Okay, that means where in how much time is he going to have $0 in this case. Okay, so in this particular problem, it is not applicable because his money is increasing. He's never going to run out of money. Okay, Roberto will never run out of money in this situation. Now, it's not talking about he takes anything out. So as long as he is increasing that money by $55, the x-intercept is not going to be part of this problem. Okay? So Roberto deposits the same amount of money each month into a checking account. Use the table to write an equation to model his balance B after n number of months. So the balance in his account is equal to $55 times the month plus the initial amount that he started with. Or you might say, if you're talking about how this all began, you could rewrite it a little differently and say 200 plus the $55 that he's putting in each month gives him the balance. Okay? Probably this one mimics more what's going on in this situation. Okay? All right, and then we've got one more on page 15. Beginning of October, Monique changed banks, decided to leave the remaining $3,900 in her old checking account to pay for rent. After 6 months, her balance was finally 0. If the balance B is a function of time, write an equation for the situation. Okay, so she had $3,900. After 6 months, her balance was 0. If the balance B in hers is a function of time, write an equation. So to figure that out, you have $3,900 divided by 6, because after 6 months she is out of money. That is going to be, 6 of 6, 36, which is 300, which is that right? I think so. 0039. Yeah. So it looks like $3,900 over the course of 6 months means that she was putting in $650 for rent. Because this is decreasing, it is not being added to, that is the slope. So that is negative 650. The real world meaning is this is the rent being paid, from her account each month. Okay, the y-intercept, again, if we think of our graph, the y-intercept is where time is often a value for your x or independent variable, and in this case, it is money that she had. The y-intercept would be how much money that she started with at time 0. So from this account that she left and was using for her rent, her y-intercept was 3,900, or 3,900. Real world meaning, this is amount, this is amount of money in account before paying her rent each month. Okay, the x-intercept is the amount of money that she has over time, and it says after 6 months, so her x-intercept is 6 or 60, so after 6 months she's going to have $0 left. So this is time and this is the amount of money. Real world, and I like putting these labels on with these actual points after 6 months. Monique has no money left in her account. And so the equation, she started off with $3,900, okay? And then her slope was minus 650 T, which left her with her balance B. So that is the final equation. Okay. So we will stop there for today. Hopefully you and your partner got some of those answers. And now you can try homework number 2, which is within Module 4, homework number 2. Try to do that. Make sure you have homework number 1 done by tomorrow, because I'm going to start looking at those online, and you can begin to work on homework number 2. All right, hope you guys have a great day, and hopefully I will be back with a video tomorrow. Thanks so much. Bye-bye.